Welcome to Elemental Energy, the podcast where we discuss how to simplify decarbonization. Here, we will introduce emerging low-carbon energy technologies and give you insight on how to navigate and support the evolving energy landscape. It is our goal to develop content to give you confidence to help transition the market and make low-carbon energy reliable and affordable. I'm your host, Marsha Leonard. Today's episode, I am joined by Nick Morris. He is part of Shepherd Power. And what is really cool is we were at the same conference this last week, which was the Advanced Reactor Summit. And Nick, I'll ask you in a little bit if you had been to one of those before, but I hadn't. This was my first year. And the movement of seeing the novel applications for nuclear, especially in the oil and gas scene, upstream, midstream, is absolutely fascinating to me. And the reason I invited Nick to join me on today's show is because his company is one of those first movers, definitely a pioneer in this space. So Nick, I'm so thankful to have you today. If you would, please go ahead and introduce yourself at a high level, and then let's just jump into the story of Shepherd Power, please.
Yeah, it's good to be here, Marsha. I love podcasts. It's the new media where people tell stories. I think stories are important for the human experience, but also the spread of information. So it's great to be here with you. I love what you're doing. Any place that gets stories out is a good thing. But yeah, Nick Morris, working on my 19th year at National Oil Marco, now called NOV. And yeah, I came from a small town north of Dallas, mechanical engineer from Texas Tech. Spent my whole career here. Most of it was spent in offshore drilling equipment. So the first, let's say 2/3 of my career, there was a massive construction boom building offshore vessels, and we were a prominent supplier of drilling kit to those jobs. And it was a once in a lifetime opportunity to experience that. And we did very well and had a good run here. Of course, oil market's been upset quite a bit since 2014, now that shale oil and gas is on the market, and had the opportunity to bounce around with a number of things that I suppose what'll tee up our conversation today is in March of 2020, I moved into a new renewables team. NOV was looking at how can we apply our expertise into energy transition subjects, namely wind and solar and geothermal and things like that. But we had a pretty wide remit to look at anything that is energy transition, good potential, and stumbled into nuclear, and have been able to turn that into my full-time job. So excited to kind of break that open with you a little bit today.
I'm excited that NOV has taken it so seriously that they have a spinoff entity called Shepherd Power. Like I remember telling you earlier, my husband was a measurements well driller, an MWD, and knowing that tech was NOV's and some of their applications for downhole support. And now they are coming as far into nuclear that they've created Shepherd Power. Please tell me the origin story of Shepherd Power and how this came to be a super focus.
Yeah. We help our customers, and sounds like your husband might have been one of them, every day with really difficult challenges with big machines and doing it at scale. And it's not uncommon for them to bring us decarbonization challenges. We've been working on this for decades. Deep water rigs, we've worked with power systems to load level them so that they don't burn as much. We've built flywheel systems, and we've worked with battery packs for land rigs. We were some of the early pioneers into e-frac. We have lots of kit that goes into the CCS markets, and then also into wind. We build and design most of the vessels that go into offshore wind construction. So we've been swirling around energy transitions for a long time. And it's funny too, because as a big manufacturer, lots of energy transition technology companies bring us stuff and they say, here's my idea, could you help us build it? And so we've seen the other side of the fence, if you will, and we have a good sense for what can be built economically and what can't. Back in 2020, we were introduced to micro reactors by someone in our traditional customer base. And they said, this is something that could be a really good option for us to decarbonize. But when we canvass the nuclear industry, we see an industry that's, it's been hurt for a long time in this country. And we don't see the scale manufacturing capability that we still have in oil and gas in the nuclear industry. And I think, we took that as a call to action. Like, on one hand, are we talking to like one rogue mad scientist from a traditional energy company? And also, like, is that really the state of the nuclear industry? So we started back in 2020 running down two parallel paths. One was, let's go meet the nuclear industry. Let's go find out, what is the state of things. And I think we very quickly confirmed that, nuclear plants are built as one-off construction projects in this country. They're stick-built largely. They've had an ever-increasing regulatory regime put on top of it, which has added a significant amount of complexity. But generally speaking, we were met with open arms because, now they're confronted with modular reactors and micro reactors and things that need to have a productized philosophy behind them, and they don't have that expertise or skill set necessarily. There are exceptions. So we made good friends in the nuclear world. And then again, to validate whether or not there is an appetite in the traditional energy sector, we went out and met a lot of oil companies. Being here in Houston, we've got access to the energy corridor, and you can hit a dozen oil companies in a day if you're aggressive. And early days, it was like, I think I was telling you this earlier, Marcia, but some of them would laugh you out of their office, and others were like, this is pretty interesting. I think a big inflection point for our moonlighting on this was back in 21. We proposed, hey guys, oil companies, maybe we'd be interested in buying these and owning them and operating them on your behalf, and you pay me for the power. And that's the traditional kind of PPA model. And that's where things really started to take a new level of interest. Like, yeah, what we need is an aggregator. What we need is someone who can drive standardization into nuclear components, someone who can help build it. And, as far as our team was concerned, there is a market validated here. It's really about how do you structure that market and drive real dollars into the nuclear industry. That's, it's very easy to Google nuclear and read about Renaissance, and you can read about MOUs and LOIs. There's still not a lot of capital moving into nuclear. And I think at our conference we were just at, you heard that, that we're not seeing the big institutional investment dollars go to nuclear yet. And what we think that's going to take is a pooled demand from a sophisticated customer base. If it's the utilities, great, but I think oil and gas has some unique interests here that can tip this over the top and start driving big changes in the nuclear industry. And that's what Shepherd Power intends to do. Be an owner operator. If we can help build things as NOV, we're game to do that. But yeah, that's what Shepherd Power is.
Whenever this movement started happening and we were talking about the industrial integration of nuclear, that was the biggest risk that we connected with our customers, is nobody wants to own and operate these or be a first mover in this space. And we we're like, who is going to step up? Who is going to do that? Who is going to be the one to take the application, make it a reality, and have them not have to worry about the workforce, not have to worry about the operations and maintenance. And so to hear that Shepherd stepped into that, I see that gap that you guys are filling. That's amazing. So tell me about your ideal application, because are you planning on working with multiple reactor developers, or have y'all settled on one technology yet?
Yep, we have a preference, Marcia, for the micro reactors. And there's no like textbook definition of what is a micro reactor, but we've kind of put some boundaries on that. And the most prominent boundary is that a reactor that is small enough that I don't need a multi-year civil construction project to site one. And so there is kind of a limit on the source radioactive material in these units that can deliver that. But imagine, rather than digging a deep hole in the ground and pouring concrete for months on end, what we envision has some legs is I need a very modest pad poured on the ground. I need a prefabricated building. And then I want reactors and as much of the plant as possible to be completely built, tested, integrated, commissioned in a factory somewhere before it comes to site. I want to bring it to the site and essentially plug and play, flange things up and turn this thing on. And those cap out about 50 megawatt thermal in terms of the reactor itself. That can deliver about 15 megawatts of electricity approximately. And there is a suite of companies out there who are designing products in that range. We have a favorite that we're working with. You know, you need to find teams who are capable that can execute across the whole value chain of nuclear. That means people who are good at fuels, people who are good at reactor design, logistics around moving nuclear hardware, and then find people who are good at plant design and put those people together. And so we do have, you know, early partnerships formed to tackle that from all different directions.
At the summit, how I introduced myself, I don't even know if I told you my name. I just threw this question at you, like hit you with a book. Was about the quantitative, how are we justifying cost around this? Like, what are we really looking at? And you said it's not even quantitative right now, it's more of qualitative and the characteristics that it's bringing. So let's talk about the value around integrating these microreactors into the oil and gas space.
Yeah, that was a fun conversation, Marcia. That is the $64,000 question everyone has about nuclear is how much is it going to cost? And
$64,000. Yes, price point, everybody.
yeah, yeah, and we're deep into that conversation. And what you learn on the quantitative side of energy costs is that energy cost is infinitely more complex than LCOE. You know, and what's in the public sphere around energy costs. You know, if you operate in Alaska or in Alberta or in the Permian Basin or on the East Coast in the Marcellus Shale, you have a vast range of costs on your energy. The other thing that complicates it is, you know, if we're talking about electricity and we're talking about on the meter versus off the meter, that's a big jump in costs there. Another one is heat. You know, electrification is not necessarily great for applying heat energy to different processes. And so, you know, when we think about nuclear, it's about, well, I've got to understand direct applications in direct geographies in order to have an intelligent conversation about costs. And lo and behold, there are places all over this continent where even the high cost of nuclear already makes sense. If you can believe sort of the academic figures of what it's going to cost to get nuclear. We can talk about that later. But so there's a lot of work that goes into quantifying and comparing costs of energy today versus what's in the future. And the cost of energy in the future is also a very difficult thing to predict. You know, we've got all sorts of carbon tax regimes that people are anticipating. Companies have made pledges to decarbonize. So it's, you know, you can model your cost of energy today, but then you've also got to model your abated cost of energy. And that sort of exposes you to renewable energy credits and carbon capture systems that have varying degrees of TRL. So, you know, we are starting to put nuclear into that comparison table and seeing where things shake out. And anyway, that's the complexity, let's say, of the quantitative side of the cost equation. But then what you and I were talking about last week was the qualitative costs of this. And I think that's an interesting one. You know, I'll give you one example, and there are several others. It's, you know, oil companies, when you show up to a recruiting event at universities, just like I was hired out of Texas Tech, you know, most college students come to oil and gas companies and think, why would I come to work for you? You're going to be gone in 5 years. I mean, energy's changing. And, you know, having a nuclear project in your portfolio could be a good thing to attract talent. Also, you know, we see these companies spinning up billion-dollar low carbon teams, and, you know, they're trying to promote what they're doing to decarbonize, and nuclear is never in that toolbox. And, you know, I think people who understand energy systems really well, and there's a lot of them in oil and gas, are really frustrated by that. Like, you know, how can you be serious about going to zero and nuclear is not even in the toolbox? I mean, there are applications which, just by the laws of physics, will never be decarbonized unless we have this in the toolbox. So I think organizations are starting to grapple with this, that, you know, there's a level of seriousness that comes with nuclear. And of course, it comes with costs and complexities too. But it's also like, you know, this is something that we can do. And if you can mobilize people to have that shared vision, I feel pretty good that traditional energy companies could execute here. And then it has, like I said, the quantitative and the qualitative effects that come from it. So quite keen on both of those.
The question that spurred this entire conversation too was I had asked Nick, has anybody done a study to look at the numbers of what the sales gas you would save? So, for example, if you're not using the gas to generate power, how much are you actually saving? And that's just one tiny variable of how they are looking to enhance the value around nuclear. So, Nick, question: what is the ideal customer that Shepherd Power is targeting, or who is the ideal customer that Shepherd Power wants to serve? Is a better way of saying that.
Yeah, this is fun. The macro on nuclear, you've got utilities, of course, are typical consumers. You've got tech coming around in a big way because of the power market and AI and all of those things. You've got oil and gas. You've got the steel industry. You've got the cement industry. We were on a call this morning. The glass industry. These are all big heat consumers. The out of all of those, the ones that we've selected as our sort of target customer base is oil and gas. And again, the technology we're bringing to that conversation is micro reactors. I want to be able to get in very quickly and build a facility where I can put this. But they're also ideal for other reasons, like, they're good at integrated project delivery. If you compare oil and gas track record, I've never actually done this academically. I know there are some scholars who've cataloged all mega projects and really who is the best. I don't know that oil and gas is the best necessarily, but I've seen big projects be delivered and experienced them personally. So I like the project capability of oil and gas. But the other thing is that we have a diversity of application. It's not just power or electron creation that oil and gas needs. They also need heat. And so, we've taken some artistic license at this point with a micro reactor, and we've placed it in a place like the Permian Basin. And yes, it can generate electrons that are extremely valuable there right now. The Permian's trying to electrify rapidly, and that's causing some really big constraints. But also around that reactor, we've got heat that we can use. Power production systems are inherently inefficient. So you've got some waste heat that you can do something with. And we've got things there like, the Permian as example, for every barrel of oil we're producing 4 to 6 barrels of water. Wouldn't it be nice if you had some heat to start doing interesting things with that water, either reduce the amount of waste or start thinking about beneficial reuse of that water, turning it into something that's maybe approaching potable water. But also, like, traditional energy is investigating hydrogen production, and we've got lots of carbon capture technologies that are in development, and most of those things need heat and energy. Pyrolysis for methane to create hydrogen needs heat. Direct air capture and other amine-based systems need heat to process all of those chemicals that go into those processes. So you can very quickly start to imagine a hub and spoke concept in a producing basin where, yes, I'm making electrons, but I'm also siting different projects around that reactor to deliver new energies. And it goes on, synthetic fuels. And I think for fun, one day with one customer, we even said, this could be the solution to the EV charging problem across the country. I mean, this country's never going to build transmission down the interstate highway systems to power all of our EVs. So let's imagine a Buc-ee's that's a nuclear reactor dotted along the highway, and that's where we pull in to charge our EVs. So, the diversity of opportunities is vast, but it's kind of like we got to thread the needle on the things we talked about earlier. What are the economics, and what is the total value of the package here? And that's these oil companies, I think, are doing a good job of starting to wrestle with this in a creative and constructive way. So that's where we live day to day.
I can totally see Buc-ee's being that first mover. For everybody who doesn't know what Buc-ee's is, if you've been to Texas, you should know. They are like the Walmart of gas stations. I mean, there's one going in next door in New Braunfels that has like 400 pumps or something ridiculous.
Yeah.
Oh,
It's
cool.
a
So
super, the only thing they're missing is a nuclear reactor.
it is. It's so true. So true. Okay. I had to fact check one of the presenters at the Advanced Reactor Summit because his fact totally, it almost made my jaw hit the floor. You're talking 50 megawatt reactors. He is saying that by 2028, or he said that by 2028, they will need 20 gigawatts of electrical power generation support in the Permian Basin. Like I said, I had to fact check him because I was like, that is a massive amount. And so for even like the tiny, I'm not saying this to like downgrade Shepherd, but that's a small like impact on that 20 gigawatts that's necessary. And so to further support how important it is that we come up with these, like you're saying, easy to install, quick to install reactor bases, it's so critical. What do we need to be doing to support Shepherd Power right now? Because I know Texas had the open welcome mat, and they are trying with their legislature and everything with the NRC to gain traction on this. But what do you need to make this happen, and when?
Yeah. Uh, Maybe one, before I give you a big, maybe provocative call to action, what I'd say is we have to think about the evolution of what's going to launch nuclear. The big power plants and the mega projects are still really suffering. That pains me as an American that we can't build big things. Why can't we have nice things? But we are really struggling to build the big mega projects. But we need them. I mean, to get to 20 gigawatts, we need all of the above. To be sure, we still need big power plants. The SMRs have a niche place. But I think on the evolution, what would really help would be fleets of these micro units strategically placed in operations to generate some qualitative value that the nuclear industry needs. Like they need communities engaged in spotting reactors in their vicinity again. And it doesn't have to be a mega project, but you could imagine if you put one in West Texas, I mean, there's going to be a community engagement that goes on there. And we assume that project's successful and people realize like, no, this is actually adding value to my community. I've got a whole new technology here that we're supporting, and it starts small and then starts to grow from there. So I think having fleets of small units is what can help crack open the broader nuclear rush. But to your question specifically, Marcia, about what can we do, and if you're coming from oil and gas, like I think you are, I think there's a recognition in oil and gas that sort of centrally planned so-called energy transition has not gone very well. And I think that's particularly clear to people and folks that are in traditional energy. And what I would say to folks in oil and gas, if you're in upstream or midstream or downstream and you deal with energy on a daily basis or even part-time, and you agree that nuclear is a good pursuit, and there's a lot of people in traditional energy. Going back 20 years, you ask them about transition, they'll tell you nuclear is the answer. Why aren't we doing more nuclear? If you're one of those people that works in this community, I think your perspective is needed. And I think you need to elevate that nuclear is something you want to work on. Energy transition nationally as a subject, it needs adults in the room. And those adults come from traditional energy because we understand safety, and we understand high consequence, and we understand scale, and we understand the distributed nature of this and how to make it equitable to the people that we work with. And so that's know that Shepherd Power is out there. We want to talk to you. We want to meet you. We want to share our vision, and we want to help you. And I think the nuclear community is ready to engage you as well, not just Shepherd Power. But if we can help anyone make connections and start to seed in, what kind of technology potential exists, we'd love to do that because it has changed. I think in 2020, we still had to field questions about Fukushima and 3 Mile and Chernobyl, and the technology has largely moved on from that. And folks need to hear about it and understand it. It's beautiful and it's eloquent and it's small and it's dense and it's safe. And I think folks in traditional energy would really latch on to that and could run with it.
Nick, I asked the same question to a very senior nuclear individual at the summit, and he explained to me the difference between oil and gas mentality and why we, quote unquote, are not good at major projects for nuclear here in the States or generally anywhere, is because it's the difference between a regulated market and a non regulated market, where utilities are typically basing off of taxpayer dollars and they have, they don't have stakeholders to appease and they just, I hate to say it, but they put it back on the community and
Yep.
they have an unlimited, not necessarily an unlimited pocketbook, but they have reach into more funds. Whereas in the non-regulated markets, we are literally pulling out of our own pocketbooks to get some of these assets built, and it puts a different mindset into the project management and development of these projects, which is why I think we were so welcomed at the Advanced Reactor Summit, is to have that different mindset and mentality come in to help establish this new, hopefully, I mean, it's going to be a regulated market, but like the kind of non-regulated mindset that we have been performing for the last 100 years in the oil and gas space.
That is the that is the changeover that nuclear is wrestling with. Marcia, is yeah, you've got essentially government mandated monopolies, which is what birthed nuclear. And now the industrial user who lives in the most cutthroat, shrewd, highly competitive, micro pennies matter in our world. It's I've sat on projects where, we've got stopwatches out and we're timing how fast we can get in and out of a well, because seconds matter, and you bring that mentality to the nuclear industry and, you can see the whites of eyes illuminate, it's like, whoa. But it's healthy, right? And I think this is another reason why we like these micro reactors so much, is that you can take that philosophy, as it were, and that shrewdness and that commodities driven kind of mentality, and you can apply it to a nuclear project that's not, it's not $1 billion, it's not half that, and so a number of companies could come together and wrestle with a fleet of these units and build the supply chain as we have done in oil and gas and change the world, and that's like this, the shale gas revolution in the United States. It wasn't that we can drill 2-3 mile laterals and frack them. It's that we could do that on a scale that's like almost incomprehensible. I mean, today I think there's 600, maybe between US and Canada, 600 something rigs working today. There's a couple hundred, maybe 300 frac spreads working today, and that's the scale that you want to bring to nuclear if you want nuclear to be successful. And that's, we have changed the world. We should be proud of that. And then we should think about how do we apply that to a new energy form.
So, for all of my fellow upstream listeners, think of turning right at all times. Turning right means that you're drilling, you're making money. And that is what nuclear is 24-hour, clean, reliable power. Ah, Nick, I am so grateful for your time and for getting to see Shepherd at what I would call its like pioneer phases. And
Yep.
I'm looking forward to supporting you guys however I can. And I'll definitely be sharing with the people who I interact with that there is somebody filling that gap of owner operating now in that space of micro reactors. So, is there anything else that you want to share with us today?
I think we covered it, Marcia. Like I said, it's great to share this with you. It's sometimes in the land of technical, commercial, detailed, and then also in the philosophical land. But both of those things matter. And like I said, to be able to put that in long form conversation is a good thing. And we're here to talk about it with him. It's going to take a village to make it work. Don't want anyone to think that we're so naive to think that we can do all of this on our own. We're going to need a lot of help along the way. And to call you a friend in that journey would be a big win today. So glad to hear it.
Awesome, Nick. Well, everybody listening, as always, stay happy, but most importantly, stay safe. Nick and Shepherd Power are what I'm calling pioneers in this space. It is so cool to see how these novel applications are taking shape and what they have answered by becoming that owner operator in that 50 megawatt space has been a huge gap that our customers are speaking about. Well, just anybody in the realm of needing power generation and thermal is speaking about is who would actually own and operate these facilities. So to hear that they're stepping into there, awesome. If you have any questions, please don't hesitate to reach out to me, Marcia Leonard on LinkedIn, MARCIA. And if you have any thoughts or even connections about this, I'm open to it all too. There's always a learning moment for all of us in this space. And if we come together, like Nick said, we can't do this alone. It's just going to strengthen the movement even more. So thank you again for listening.